What is Mars entry, descent, and landing EDL? Imagine a spacecraft speeding through space, heading toward a planet with a thin, dusty atmosphere. Now picture it having to slow down from thousands of miles per hour to gently touch down on the surface. That's what Mars entry, descent, and landing, or EDL, is all about. It's a complex series of steps that make sure the spacecraft reaches the surface safely. First, the spacecraft enters the Martian atmosphere at hypersonic speeds, which means many times faster than the speed of sound. This part is called the entry phase. The spacecraft faces intense heat because of friction with the atmosphere, so it's protected by a heat shield. The heat shield absorbs and dissipates the heat, preventing the spacecraft from burning up. During this phase, the spacecraft uses aerodynamic forces to steer itself toward the designated landing site, adjusting its angle and trajectory carefully. Once it passes through the thickest part of the atmosphere, the descent phase begins. The spacecraft slows down even more, often deploying a parachute to reduce speed from supersonic to subsonic levels. This is when the heat shield is jettisoned, and radar systems come into play to measure altitude and velocity. These measurements help the spacecraft prepare for the final step. The last part is the landing phase, also called powered descent. Here, the spacecraft uses rockets or thrusters to further slow down and control its descent. Some missions use a special technique called the skycrane maneuver. In this process, the descent stage lowers the rover on cables to the surface and then flies away to a safe distance. The goal is to land gently and accurately, avoiding rocks, slopes, or other hazards. EDL is considered the most dangerous part of a Mars mission because of the planet's thin atmosphere, high entry speeds, and the need for precise control. Communication delays mean mission teams can't control the landing in real time, so the spacecraft must perform these maneuvers on its own. That's why astronauts training for future Mars missions spend a lot of time practicing EDL in simulators. They learn how to handle unexpected situations, manage timing, and make quick decisions. Advances in heat shields, parachutes, propulsion, and autonomous guidance are helping make Mars EDL safer and more reliable. These improvements are key for future human spaceflight missions, as they will need to land safely on Mars to establish bases and explore the planet. Traveling to Mars will require perfecting this process, so understanding EDL is a big step toward making human missions a reality.